Okay. So if you see the teaching plan, okay, uh, what we are going to do in this case means basically in this course is this will cover actually unit 3 complete course, because this is a very important chapter which will help you to not only just to prepare for UGC net. In addition to UGC net, it will be helpful for other you can say competitive exam also, and your overall knowledge, and it will help you also in MA economics course wherever the exam you are writing. So you can see, so I have divided the whole course to module 9 modules, okay, and it will complete in May last week, okay. So you can see probability theory, descriptive statistics, sampling methods and distribution, statistical inference and hypothesis testing, linear regression model, identification problem, simultaneous equation model, discrete choice model, time series analysis. So completely we'll be doing it like weekly, 3 days per week starting from today. It means next week we are means next week we will have 2 more classes, okay, this week. So like that, and whenever I will get extra time I will cover. So that will be like weekly at least 3 classes, 1.5 hours each. So day one, like today, which we will discuss. So although like we are little late week one, so gradually it will be. So all the syllabus are given over here. I think in detail it is given. Exercises will be also given to you, so that you will be comfortable yourself. You can do the assignment. Okay. So uh, we will also have a midterm test also, okay, and complete course, okay, this is a complete course, and all other details are given over here. Which book you want to you will prefer, means you will refer, and we are also going to do some basic software which we will be also using, okay, and but our focus will be UGC net, okay, because the course is actually following UGC net, means this whole course is based on the unit 3. So if you have any doubt, you just you can ask me later on when we will end the course. So without wasting much time, because I think we'll start today's journey. So week 1, day 1, introduction to probability theory, okay. So what I am assuming over here is, I'm assuming that you all don't know, and like maybe you are having very basic rudimentary knowledge on probability, okay. With that assumption I am going to start. So some of you, if you know it, then you can just review your understanding. If you think that okay, these are the concepts already we know, then what is the need that we we will study again. But probability and math is such concepts where you need lot of revisions, and gradually you can achieve whatever you want to uh, plan for your net exam. So let's see, let me hide this. So today this is what we are going to cover: why study probability, basic concepts, experiments and outcomes, what is probability, 3 ways to find probabilities, probability rules, conditional probability, and practice problem and key takeaways. So if you will see last couple of years, previous year question, you will see, you will find probability numerical problems on conditional probability, So this section is very crucial. Okay, so please try to understand that probability will at least get you at least 3 to 4 questions. Means 8 mark. If you are going to do it very seriously, 8 marks will be there for you. So now, why should economists, like you all are economists, right? So they will care about the probability because life is full of uncertainty. We don't know actually what will happen tomorrow. So in economics, we think whether the stock market will go up or down, what are the chances of getting a job, moreover, what are the chances you are going to get UGC net June to that 2026. So that is uncertainty. Will inflation increase next month? What is the risk of a business falling? And in daily life, we ask like this: will it rain tomorrow? Should I carry an umbrella? What are my chances in an exam? Should I buy insurance? So all these questions usually comes to our mind, but whether it is consciously or unconsciously, we try to seek the answer for all these questions. So probability help us to make smart decisions under uncertainty. If you will ask, if you don't know probability, what will happen? So obviously you cannot make the smart decisions. It will help you to get the smart decisions. So now it's first a simple question we'll start with. If you toss a coin, what are the chances it lands on heads? Simply 50%. We know that either we will get head or tail. So it is 50% or half or 0.5. Right? So it means if you know that there is a 50% chance that we are going to get the head, it means already you know you have understood or you understand the probability intuitively. So, but we need to formalize what already you know, right? So let's try to understand. We'll understand with the first, what is an experiment, right? So any action, what is an experiment? Basically any action or process that leads to one of several possible outcomes. So for example, one, tossing a coin. So you can see there are two possible outcomes. One is head, second one is tail, right? And moreover, if I'll see uh, the probability of getting head is 0.5, probability of getting tail is 0.5, right? So you can use this kind of diagram are called tree diagram. So tossing a coin, 1 second. So tossing a coin, so it is like head, H, tail, like that you can do. Okay, so you can just try to understand in this way also, not a problem, whatever the possible way. I'm just telling you to just be aware about it. You can do it later on, not a problem. So next one is rolling a die. So let me see if anyone want to. Okay, 1 second, just give me a second. Okay, sorry for the interruption. So, similarly, you can say that example number 2, rolling a die, possible outcomes are 1, 2, 3, 4, 5, 6. Example 3, drawing a card, possible outcomes are 52 different cards. So, we can list what we learn from here. We can list all possible outcome before the experiment. Okay, because when we started that the experiment means any action or process that leads to one of the several possible outcomes. So you have to list all possible outcomes, right, before the experiment. So now let's try to understand further. Okay, so please pay attention, because if you will lose your attention, then you might not able to comprehend, even though I will be going very slow today. Okay, so that it will be at least we all will learn from whatever we are going to do tomorrow, sorry, today. So first one is experiment. Let's say that what are the economic examples of experiments. Experiment number 1, job interview. What is the action over here? Attending a job interview. What are the possible outcomes? So am I audible? You can use the chat box to answer me. I hope I am audible, right? Yeah? Okay, thank you Ajay for confirming that. So now experiment number 1. You are attending the job interview. What are the possible outcomes? Either you will be selected, or you will be not selected, or you will be waitlisted. Experiment number 3. Experiment number 2. You want to invest 10,000 in buying the stocks. There are 2 possible outcomes. Either you will get profit or you will get loss. Suppose experiment number 3, product launch, launching a new product. Possible outcomes will be successful or moderate success or failure. Experiment number 4, auction bid, bidding in an auction. Possible outcome is win the auction or lose the auction. Now I'll write one more action, experiment. What is that? Experiment number 5. I will simply write E5. What is that? The UGC net June 2026. So what are the possible outcome? Either you will clear or you will not clear, right? So there are 2 possible outcomes. So similarly, you can write like some more examples of experiment, and then list out what are the possible outcomes in each one of them, right? So that you can understand that, okay, the outcomes very clearly, correct? So now let's move on to the next. So now once you can list out the possible outcomes, now it is time for defining what is sample space. So first of all, we write sample space like you can see S. So what is it? Sample space is basically the inverse of possibilities. It means the set of all possible outcomes of an experiment. So example number 1, coin toss. So sample space either head or tail. So 2 possible outcomes. Example number 2, die roll. The sample space is 1, 2, 3, 4, 5, 6. There are 6 possible outcomes. Example number 4, let's say that what will be the gender of a child? So it will be either boy or girl. So there are 2 possible outcomes. So you should know how to define the sample space. Then next topic is events. Please see the sequence how we are doing the transition. First we have defined the experiment. Then we have defined the sample space. Then we have defined the events. That's how you will be progressing. Then event, what is an event? Event is a subset of the sample space. It is one or more outcomes that we are interested in. For example, rolling a die. So sample space, already we know that there are 6 possible cases. So from all these possible cases, I can have one or more events. Event A, let's say that. Event is getting an even number. So what will be my sample space? You can say my event is basically from the sample space I can find out my event. So that is 2, 4, 6, which are even number. Then event B, getting number, basically getting a number, I think greater than. This is actually this, there is a typo error here. So the event B is, you can see, so this is actually greater than. Okay, so greater than, getting a number greater than 4. So obviously there are only 5, 6 which are greater than 4. Event C, getting a 1. So obviously in this case only 1. Getting a number less than equal to 6. So it will be all 1, 2, 3, 4, 5, 6. So again and again I am telling you, event is a subset of the sample space. Okay, so don't get confused. So now let's practice. Experiment you have applied to 2 universities, University A and University B. Now in this question, what is the sample space? Please write it down in the chat box. I am giving you 2 minutes. I hope the question is clear to you, right? Yeah, so I want to see your participation. So in the chat box, please write the sample space. Just you write, yeah. Both A and B are sample space. Very good. A and B. Very good. Chinmay. Okay, excellent. Swapna also rightly answered. Very good. We got very good questions. So now, just see where you went wrong. Sample space is A, B, A or B dash. Basically, you can say B bar or B complement also we will say. Let's say that means if you are getting rejection, you say A bar. A bar B also. A bar B bar also. So A is either you will be admitted to A bar is you rejected from A. So there are 4 possible outcomes. But now let's say let's try to listen. Madhusmita, what made you to answer A and B? Is my answer wrong or your answer is wrong?
Sir, my answer is wrong. Actually, I do not recall. There is a 4 possibility.
Yeah, but you are not thinking critically.
Yes, sir.
Now you have started with your answer A and B, so others also followed, isn't it?
Yes, sir.
Okay, please. That is why in even if in UGC net also, I am 100% sure you are not understanding the question and straight away jumping into answer. Okay, but in probability there is a high chance that you will make it wrong if you will have this kind of practice. Okay, so thank you. Now we'll try to understand Chinmay. Why?
Yes, sir.
Why you have answered A and B? Whether your answer is correct?
No, sir.
Then why this kind of mistakes?
Sir, I think The sample space is in both. So,
Both A and B. But you have to think, na? Either because it is my candidate sample space basically, not the universe means the possibility only for the applied. Because that is what it is saying. You applied to university, right? So next time, please don't jump into the conclusion. Okay?
okay, sir.
Read carefully before you answer. Right?
Okay, sir.
Okay. Thank you so much. Now, next. So there are four possible outcomes. Correct. Now, question number 2. If you have understood, define the event. I get admitted to at least one university. Now, Madhusmita,
Sir, either A or B.
you write it.
Okay, sir.
Because if you will write, it will be recorded. So you will see what is your answer. Chinmay,
Yes, sir.
what is the event? Can you define the event? I get admitted to at least one university.
Sir, A, B bar and A bar B.
Okay, very good. Let's see. And others, you are not participating. Sapna,
Okay, sir.
okay. You have understood the question? Means you have to define the event, right? I get admitted to at least one university. Okay. So now I will come back to the answer. So now the question is, the answer is A, B or A, B bar, A bar, B, right? So there are three favorable outcomes. Correct? So how many, Chinmay, you are saying earlier?
2.
Why 2?
A and B.
At least na it is written. So maximum possible cases will be written over here, A and B na. A and B, either I will be getting admitted into to the university A or I will be getting admitted to the university B. So both are 2, A and B bar 1, A bar B also possible and both A and B also possible. At least it is written na. Are you getting my point? At least. So
Yes, sir.
emphasizing the word is very important over here. Are you getting? Madhusmita, what was your answer?
Sir, my answer is mutually exclusive. A intersection B.
What do you mean by intersection B? Means, wait, just you tell me whether this answer is, you agree with this answer or not. Don't tell anything
No,
else.
sir, I agree with this answer.
Okay, very good. So you just see, this is a very simple question, but most of you are going wrong. Why? The reason is you are not reading, you know the answer, but you are not thinking before you answer. Then obviously the answer will be wrong only. Are you getting my point? So please try to emphasize the word at least one, at most, at least. So we'll see that. So now, next we'll start probability. Probability is basically measuring the likelihood. So probability is a number that tells us how likely is something going to happen, right? So the probability scale is how? Impossible, 0. It means the event will never happen. Unlikely, that is 0.25 probability. Equally likely, 0.5. It means the event has a 50-50 chance. Then likely, so it is 0.75. almost certain, when the event will definitely happen, that is probability will be equal to 1. So real life probability examples, very low probability, winning a lottery, right? Uh, being struck by the lightning, probability will be very low. Low means low probability means it means probability is equal to at least 0.25. So getting heads twice in 2 coin tosses. Rain in Odisha in December and 50-50 head in a coin toss. Baby being a boy, high probability getting at least one head in 2 coin tosses. Clearing UGC net June 2026 if you studied well. So it is a high probability 0.75. Very high probability sun rising tomorrow 0.99. Monsoon in Odisha in July. Certain getting a number less than equal to 6 on a die. Today becoming yesterday. So you are almost certain. Right? So these are some interesting real life probability examples. Apart from the like textbook example, we have included some real life example to motivate you. Now, method number 1, how to calculate probability? Classical probability. Classical probability means equally likely outcomes. So probability of event is basically the number of favorable outcomes divided by the total number of possible outcomes. So when you need to use this, when all outcomes are equally likely. Correct? All outcomes are equally likely. Like coins, dice, cards, already which you have used the examples. So there the outcomes are equally likely. Suppose example number 1, die rolling. So probability of getting a 5. The solution is favorable outcomes is only 1, that is 5. Total outcomes is 6. So probability of getting 5 is 1 upon 6, that is 0.167. Then probability of even number. Already the event you can write. Favorable outcomes are 3, that is 2, 4, 6. Total possible outcomes are 6. Probability of getting a even number is 3 by 6, that is 1 by 2, that is 0.5. Right? Next is drawing a card. What is the probability of drawing an S from a deck of 52 cards? So solution is number of S in a deck, you can see 4. Right? I think those who have played, then those who have not played also you can check. Right? Total cards are 52. Probability of S is 4 upon 52, that is 1 by 13, that is 0.077. So example number 4, 2 coin tosses. What is the probability of getting exactly one head? Now let's try to understand. Sample space is S is HH, HT, TH, TT. 4 outcomes will be there. And favorable outcomes are head, tail, tail, head. 2 outcomes. Because we are saying exactly one head. So probability of getting exactly one head is 2 by 4, that is 1 by 2, that is 0.5. Correct? Now, so method 2. So first method is classical method. It is very easy. Relative frequency, that is empirical probability method. So what is the formula? Probability of getting an event, that is number of times event occurred divided by the total number of trials. When you need to use? When we have data from the past experience or experiments. Suppose for example, student pass rate. In the last 5 years at Government Women's College Jaipur, 1000 students appeared for economics exam, 850 students passed. Now, what is the probability a new student will pass? Yes, can you write the answer in the chat box? No one is writing the answer. It means, okay, how we will find out probability of pass? Simply you have to divide. So this kind of questions you need to answer very fast, otherwise you are not alert. Okay, so probability of pass is 850 divided by 1000, right? So it will be 0.85, which is 85%. Now weather prediction. The weather data for Jaipur in July over 30 years, total days in July over 30 years. Thirty into 31, 930 days, right? And how many days it rained? 750 days it has rained. So what is the probability of rain on any July day in the city Jaipur? So who will calculate the probability? Let us see. Yes, Madhusita, are you there?
Yes. Yes, sir.
What is the probability? I am not able
Sir,
to
I
see
think
this.
80%.
Huh?
80%. 0.80 means 80%.
Okay. Chinmay? Chinmay is not there. Okay, very good. So 750 divided by 930. So it will be the probability is as Madhusudha told 0.806, that is 80.6%. Okay. Now similarly job placement. There are, let's say, that economic graduates from Bikramdev University. So there are 200 graduates passed in last 2 years. 140 got job within 6 months. So what is the probability of getting a job within 6 months? Okay. So simply you can divide 140 upon 200. Right. So similarly, next is method number 3. We will get to method number 3, subjective probability. That is personal judgment. So it is based on personal beliefs, experience, intuition or expert opinion without mathematical calculation. When to use? When we have no data and outcomes are not equally likely. Example number 1, I think there is a 70% chance India will win a cricket match. So you are saying based on the team form, player performance, pitch conditions. So example number 2, there is a 60% chance I will get this job. Example number 3, the stock market has 80% chance of rising. Example number 4, this business has 40% chance of success. Or example number 5, I have 90% chance that I will clear the UGC NET June 2026. So these are subjective probability. That is based on the personal judgment. Okay. So quick comparison. So there are 3 methods we learned today. So classical method, relative frequency method and subjective method. So when you need to use classical method, when the outcomes are equally likely. Relative frequency, when there is a historical data is available. Subjective, when there is no data on equal chances. And the example of classical methods are coin toss, die roll, card roll. Then for relative frequency, pass rates, weather pattern, job placement, and subjective, stock market prediction, sports outcome, expert opinion, and so on. So this is our final takeaway. So all 3 methods give a probability between 0 to 1, but they are used in a different situation. Is it clear, Madhusindra?
Yes, sir.
Earlier you know which
Yes, sir.
method
I
when
know,
to use.
sir. No, sir. Actually, I know, sir, but I forget.
Okay, now don't forget. Okay.
Okay, sir.
Okay, thank you. So now we have the enough background knowledge of events, sample space, experiment. Now we'll move to the 3 axioms of probability. So what are they? Axiom number 1, non-negativity. So probability is always between 0 to 1. So it means you cannot say that I will write UGC NET June 2026 exam and there is a negative 100% probability. Madhusudha, can you say like this?
No, sir.
Let's say that you will say that I will not write the exam. Then still whether it is a negative number?
No, sir.
Then what will be the number?
0.
0. Very good. So technically you cannot have negative probability or probability greater than. Always you remember there is a typo over here. Whenever this mark is there, question mark, I think I will correct it. So please read it greater than. Okay. So you cannot have negative probability or probability greater than 100. Axiom number 2, certainty. The probability of entire sample space is 1. So probability of S will be equal to 1. Something must happen. One of the outcome will definitely occur. Okay. What is the next one? Additivity, which I think Madhusmita was telling, that is for mutual exclusive events. If event A and B cannot happen together. Okay. So there is actually little, I think it is not overlapping, but I can see what it is written. Probability of event A and B cannot happen together. Like for example, probability of happening head and tail are mutual exclusive. Either head will, when you are tossing coin, you will get either head or tail. Understanding the mutual exclusive event. Now the definition is mutual exclusive event. What do you mean by mutual exclusive events? So is it full screen or not? Yeah, let me see. Yeah. Okay. So now, because I see, yeah. So this is the definition of mutually exclusive events. Two events that cannot happen at the same time. So mutual exclusive event S means what? And not mutual exclusive means what? So getting head or tail, you cannot get both, as already I told you. Rolling 2 or rolling 5. Being in Delhi or Mumbai at the same time. Student passing or failing. So these are mutually exclusive events. Not mutually exclusive, getting even number or number greater than 3, I think, yes. Because 4 and 6 are both, right? So, being a female or being an economist. So, raining or being cold. Drawing a king or drawing a heart. Because king of hearts is both. So the question is, what is the most important question is, can both events happen at the same time? If no, then mutually exclusive. Okay? Because you will get lot of question which will be using this concept. What is mutual exclusive events? Now let's see. So now, if events A and B are mutually exclusive, you will write like this: probability of A or B is equal to probability of A plus probability of B. So now please find out what is the probability of rolling a 2 or a 5. Is the question clear, Madhusmita?
Yes, sir.
Okay. Please tell me the answer quickly. Chinmay, is it clear? Chinmay is not there. Ajay, is the question
Yes,
clear?
sir.
Yes, sir.
Okay. So what is the probability? Calculate it. Okay. As you are taking a lot of time, so let me find it out. So what is the solution? Probability of 2 is 1 by 6. Probability of 5, 1 by 6. So these are mutual exclusive. You cannot roll both, or means mutual exclusive. So you have to add them. So probability of 2 or 5, that is 1 upon 6, 1 by 6 plus 1 by 6, that is 2 by 6, that is 1 by 3. But how much time you took, Madhusmita, for this?
Sir, actually, I forgot all this.
Chinmay,
Yes, sir.
why you took so much time to tell this answer? You know earlier, or you had forgotten?
No, sir. I know earlier.
Then you should have told instantly, na? 1 by 6 plus 1 by 6. At least that much answer you should have told, right? So probability of rolling, knowing and not telling means what? It means it is equivalent to that you don't know. So probability of rolling a 2 or a 5. So you have to simply add the probability of A plus probability of B. Example number 2 will not go. So better we will start with general addition rule. When events can overlap. So please write it down for any two events A and B. So that is probability of A or B. So that is probability of A plus probability of B minus probability of A and B. Why subtract? To avoid the counting the overlap twice, because the both overlapping region should counted in A, because in A also both is there, in B also both is there. So that is why we have to subtract them. Try to understand the formula. You don't have to mug up. Already you know that addition rule means probability of A or probability of B. So only when it is overlap is there, so you have to subtract it. Now let's try to understand. So in a class of 100 students, 60 students study economics, 45 students study mathematics, 25 students study both economics and mathematics. Now what is the probability of randomly selected students? A randomly selected student studies economics or mathematics. So Madhusmita, I am giving you 2 minutes to answer this. Chinmay, are you there?
Yes, sir.
So try to answer this, okay?
Okay, sir. Okay, sir.
Okay, very good.
I'll-
Mute yourself. Shivani, are you there, Shivani?
Yes, sir.
Shivani.
Yes, sir. I'm there.
So what is the answer? Are you calculating?
Sir. Yes, sir. I'm calculating.
Okay, how much? What is the answer?
Sir,
Ideally, yes. Tell me.
0.80.
Zero. Okay. Chinmay, what is your answer? Chinmay,
Yes, sir.
what is
Sir,
your answer?
sir.
It means you didn't get the answer.
No, sir. I was calculating.
Okay, you keep on calculating. What is the answer, Shivani?
Sir, 0.8.
Okay, very good. So now let's see why you will not take so much time. Just already we have. I don't know why you are taking so much time. 60 students are there in economics. So probability of economics plus probability of math minus probability of both. Simple. 25 students they study economics, both economics and mathematics. So we have to subtract them. Simple. I don't know actually what is the problem over here. Uh, right? Because already the formula we had written earlier, probability of A or B, that is equal to probability of A plus probability of B minus probability of A or B. We had written. Let's see. I think probability of A and B. Huh. Both. I think when we are discussing for UGC NET December 2025, I told you a tricks, right? Chinmay, when to
Yes, sir.
use and when to use or. Did you remember?
Yes, sir.
And or. Tell me. And means what? Or means
And means intersection, sir. Or means union.
and means intersection. Okay. Or means
Yes, sir.
union.
Union.
Very good. Excellent. You got 0.80 now? Answer?
Yes, sir. Yes, sir.
Okay. But your answer time is very long.
Sir, actually.
Okay. Try to do it in a less time. Okay. So
Okay, sir.
I hope the other students are also able to calculate it. Right. So if you are able to calculate, you can give your thumbs up. Okay. In chat box. To make it that okay, you are also following. Now let us go to the next. What is it? The multiplication rule. This is very important. Okay, let me wipe it out. So first of all, try to understand what we are trying to discuss over here. Multiplication rule for the independent event. Okay. So two events where the occurrence of one doesn't affect the probability of the other. First of all, try to understand what you mean by independent events. Two events where the occurrence of one doesn't affect the probability of the other, right? So multiplication rule for independent event, that is if A and B are independent, so as so you can see probability of A and B. Okay, always see as Chinmay told, intersection. And means intersection or means union. So that is very important to understand or just keep in your memory. So probability of A and B will be equal to probability of A into probability of B. So independent, yes, and when it is not independent. So if you are tossing a coin twice, then it's independent. Rolling 2 dice, it is independent. Drawing a card, replacing it, and drawing again. Not independent, drawing 2 cards without replacement, studying hard and passing the exam. So smoking and long digits. So you can see they are not independent. Now multiplication rule. Example, probability of getting head on both tosses. So you have tossed 2 coins, right? What is the probability of getting heads on both tosses? Chinmay, whether you will be able to solve it?
Yes, sir.
Okay, do it quickly. Shivani?
Yes, sir. I'm doing it.
Okay, very good. Uh, Madhuswida?
Yes, sir.
Are you doing it?
Yes, sir.
Okay. Okay, Chinmay, what is the answer?
1/4.
Very good. Very good. Excellent. First toss, you will probability of getting head is 1/2. Second toss, probability of head is half. Both are independent events because you are doing not only one coin, there are 2 coins, you are tossing it. So the events are independent. So probability of head and head, both are independent events. So half into half, that is 1/4, that is 0.2. Okay. So I think those who have not understood, you can tell me. So now next question. Probability of rolling a 6 on both dice. Okay, Chinmay, time starts now. What is the probability of rolling a 6 on both dice? Quick, we want to finish. Madhuswita?
Sir, 1/36.
Okay, very good. 1/6. 1/6. It is 1/36. Very good. Excellent. Now next question. I think Sangeeta, you are asking this question, right? Why conditional probability? You are interested to learn, right?
Yes, sir.
Okay, very good. But I hope you are able to calculate all other things. I think I didn't take your name.
Yes, sir. I have answered in the chat box, sir.
Okay, very good. Excellent. So now let's try to understand what is conditional probability. So what is the probability of A given that B has already happened? So the notation is probability of A given B. So you have to read as probability of A given B or probability of A conditional on B. Right? It means what is the probability that you will pass the UGC NET exam given that you have studied hard? Okay? So I think key idea here, it is actually little bit hidden. I'll change, but I know what is written over there. But now Sangeeta, whether you have understood, means are you able to get it? The example means
Yes, sir.
means when we will say conditional probability, means basically you are trying to find out probability of one event based on the another event which has already happened. Probability of clearing UGC NET December 2025. It has depended upon what? How seriously or how you have studied hard. Yes or no? Then second example, what is the probability of rain given that it is cloudy? Probability of rain given it is cloudy. So now, what is important over here? What is the key idea? The key idea is extra information, which is condition, which will change the probability. Okay, that extra information, that condition, because your probability of, this is very interesting, your probability is dependent upon, means suppose let's say that now you will say whether I will clear my UGC net December 2025. You will say, sir, I will not study, but I will clear. So what is the probability? Let's say that 0.40. But now if you will study, so your probability will increase by further 0.10. Are you getting my point? So now it is the extra condition which will change the whole game together. That is why it is conditional probability. Right? So now I hope you have understood. Sangeeta, whether you have understood or not.
Yes, sir.
If you have any doubt, you can ask me. Now we'll go to the conditional probability formula. Okay? What is the formula of conditional probability? Very good. So now you just see, you will write like this. Probability of A given B, which is equal to probability of A and B divided by probability of B. Provided that probability of B is greater than 0. Please write it down. So now what is the intuition over here? We are now only looking at cases where B has happened. And out of those, how many times did A also happen? So A and B, can you see the, means just try to see the sample space. B has happened, then A and B has happened. We are now looking at only case where B has happened. Out of those, how many times did A also happen? Are you able to understand, Sangeeta?
Yes, sir.
First try to understand the intuition.
Yes.
Means what is happening over here? The whole sample space, first you are looking at where B has happened, right? Then out of those, how many times did A also happen, right? So first graphically if you will see, then you will be able to understand the conditional probability. Shivani, are you able to understand this graph, means diagram? Shivani?
Yes, sir. Yes, sir.
So conditional probability, you will be able to do the answer, right? Means any solve, right? Question. Okay.
Yes, sir.
Now we'll come to the question. Now question is there. Please note it down, this formula. So based on this, we are asking the question. First scenario, you draw one card from a standard deck. Now again and again I am telling you, in a deck of card, 52 cards are there. So what is the probability that the card is a king given that it is a face card? Means okay. So some of you might not be knowing how to play cards, so that is why let me give you the answer quickly. So A is card is a king, B is card is a face card. So there is basically J, Q, K. Face card in deck, that is 12, 4 jacks, 4 queens, 4 kings. So probability of B will be 12 upon 52. So kings that are also face cards are also 4. So probability of A and B are 4 upon 52. Sangeeta, is there any problem?
No, sir.
Okay. So some of you may be not knowing what is face card, jack, king. Okay, just make yourself comfortable. So now, probability of king, given that it is a face card, so you can just use the numbers. That is why I have shown you the answer. So probability of A and B divided by probability of B, that is equal to 4 by 52 upon 12 by 52, that is 4 by 12, that is equal to 1 by 3. Okay? Chinmay, is it clear?
Yes, sir.
Okay, very good. Next example. After you completed your masters, let's say that we did the survey. Thousand people. So college degree, someone is having has a job without college degree. Let's say that 50. They are not having any job, so total is 500. No degree, they have a job 300. No degree, no job, there is 200. So there is 500 in together. So total is 750 plus 250, that is 1000. Now what is the probability of having a job? You have to use the conditional probability. Chinmay,
Yes, sir.
are you going to solve this?
Yes.
Or you need help in solving this? Madhusudha, are you helping? Sorry, are you solving?
Sir, actually, I am confusing.
Why you are confusing?
Sir, having probability of having job is 750 divided by 500. So what is the condition here?
Okay. Condition you are not able to understand. So
Yes.
from the fact, from the data, you have to understand the condition. First is what? Already you have told the answer. Probability of having a job is 750 divided by 1000, that is 0.75. Second, probability of having a job given college degree. College degree is the condition. Are you getting?
Yes, sir, yes.
So don't get confused. You know all the answer. Okay?
Yes, sir.
So what is that? So it is probability of job given degree is 450 upon 500. Yes or no? That is 0.90. That is 90%. Sangeeta, are you able to understand?
Yes, sir.
The crucial thing is important to know what is the condition and what is the formula. That's it. So now having a degree increases the job probability from 75 to 90%. Okay? Is it clear? Now,
Sir, I have a doubt.
no, I will come to the doubt later on. Let me complete it, okay? Because I will take your question, okay, Ajay? Because we have to finish. We are getting late, huh? I'll clear the doubt. Is it fine, Ajay?
Yes,
Hello?
sir.
Okay.
Yes, sir.
Let me finish, okay, fast, because today's session is going little uh, stretching. We are stretching today's session. So, definition using conditional probability. So, event A and B are independent if and only if probability of A given B is equal to probability of A. What is the meaning over here? Knowing that B has happened doesn't change the probability of A. This is very important. Okay, Ajay, are you writing it down? Knowing that B has
Yes, sir.
happened doesn't change the probability of A. So that is why probability of A given B is equal to probability of A means this. So it means both A and B are independent. Right? Yeah, mute yourself, mute yourself, mute. Mute all. Let me mute. Yeah. So now, so independent. So let's say that there are two coin tosses. Probability of H2, that is 0.5. Probability of H2 given H1, that is 0.5. It means first toss doesn't affect the second. Not independent means cards without replacement. Probability of S 4 by 52. Probability of S given S1 That is 3 by 51 because it is saying without replacement. Then first draw will affect the second, right? So similarly in the coin tosses, first toss doesn't affect the second. So both you can say that the probability is 0.5 over here. But in this case, not independent, first draw will affect the second over here. So now practice problem. Now we are going to end the session. Practice problem. So a bag contains 5 red balls, 3 blue balls. You draw 1 ball at random. What is the sample space? What is the probability of drawing a red ball? What is the probability of drawing a blue ball? What is probability of red plus probability of blue? And why does this make sense? Okay, Chinmay,
Yes, sir.
are you able to understand the question?
Yes.
Are you able to answer it?
Yes, sir.
Okay, very good. Let's see the answer. All of you are given 2 minutes. Sangeeta?
Yes, sir.
Okay. I am giving you 2 minutes. Let's see. Okay, I hope you have solved it. Chinmay, what is the answer? What is the sample space? Sample space is R1, R2, R3, R4, R5, B1, B2, B3. So there are 8 balls. So is Madhusudha, is it correct? You got this? Next,
Yes, sir.
probability of red. You got this, Chinmay? Yes
Yes.
or no?
Yes, sir.
Okay. Then why you are not telling the answer?
Sir,
Probability of blue 3 by 8. You got this also? Yes or no?
hello?
Hello?
Yes, sir.
Then probability of red plus probability of blue. How much?
It's
5
one.
by 8 plus 3 by 8, which will be equal to 8 by 8. That is 1. Why you got this kind of answer? because these are mutually exclusive and exhaustive events, right? One of them must happen, so probability will add to 1 only. Are you getting my point or not? Chinmay?
Yes, sir.
Okay. Sangeeta, you have understood? If you have not understood, don't worry. We will discuss more on this. Okay? First you do the solution. I think Madhusmita,
Yes, sir.
you have understood or not?
Yes, sir, I have understood.
Okay. But you are not confident. So let's do the
No,
practice
sir, I
problem.
chat the all answer in chat box.
Okay, very good. I have not checked. So next question. Let's see. You roll two fair dice. What is the probability of getting a sum of 7? What is the probability of getting doubles? Are the event sum is 7? Getting doubles are mutually exclusive. So hint is given over here. First think about all the possible outcome. Because we are getting late, I will wind up. So I am giving you the answer, but you after the class, I will upload the slide. So please go through it. All those who are not able to solve it. So now, so first of all, we are rolling two pair dice. So rolling dice with 36 possible outcomes. Sum of 7. Just you try to find out 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. 6 outcomes. So 6 by 36, 1 by 6, 0.167. So doubles 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So 6 outcomes, 6 by 36. Again 1 by 6, that is 0.167. Are they mutually exclusive? Yes. You cannot have sum 7 and doubles at the same time. So for doubles, sum is always even. So 2, 4, 6, 8, 10, 12. Never it is 7. Is it clear? Chinmay?
Yes, sir.
Sangeeta?
Yes, sir.
Okay, very good. I hope Shivani you are getting it, right?
Yes, sir.
Okay, very good. Next question. At Bikramdev University, 40% students are male. Among male students, 30% study economics. Among female students, 50% study economics. What is the probability that a randomly selected student is male and studies economics? What is the probability of a randomly selected student studies economics? Given that a student studies economics, what is the probability that the student is female? This is a very challenging question. So, what is the probability that the student is female? So, you think step by step. How? Let me do it. You can practice it at home and later on you just tell me. So, probability of male 0.4, probability of female 0.6, probability of economics given he is a male student, that is 0.3, probability of is a economic student given that she is a female, that is 0.5. Then probability of both means male and econ, that is probability of male into probability of econ given male, that is 0.4 into 0.3, that is 0.12, that is 12%. Probability of B, that is probability of econ, right? So that will be 42%. So after the class you spend time, and still if you are not able to solve it, we will do it also in the next class. Don't worry. So probability of female given given she is an economics student, right? Because you just see, given that a student studies economics, what is the probability that the student is a female? So last part. So you can find out. How you will find out? Probability of female and upon probability of being the student, economic student. So that is 0.30 upon 0.42, that is 5 by 7, that is 0.714. That is 71.4% probability. Right? So this question is tricky, just you have to think and then we'll discuss if you are not able to understand it. So it means probability basically what we learned today. What we learned today? We learned today is basically uh, Probability measures how likely an event is between 0 and 1. There are three ways to find probability: classical for equal likely outcomes, relative frequency from data, subjective from personal judgment, addition rule, mutual exclusive, basically probability of A or B, that is probability of A plus probability of B, general probability of A or B, that is probability of A plus probability of B minus probability of A and B, multiplication rule for independent events, probability of A and B, that is probability of A into probability of B, conditional probability, probability of A given B, that is probability of A and B given probability of B. So it measures the probability of A given that B has occurred. So I will upload the slides. Please go through again the numericals. Those who have not understood, then you just tell me. No. So now this reference card, please make a note. This reference card is given. You can note how to take notes in your class. So now, what will be the next class? Next class will be on the random variables. We learn what is a random variable, discrete versus continuous random variable, probability distribution, expected value and variance, real world application in economics. So what is the homework for today? Review today's examples. Try and practice problems again without looking at the solution. Think of 3 real life situations where you use probability thinking. So now you have to upload this homework. Class wise, I will create the homework, take the snapshot. Okay. Let me end the recording. Where is the recording?